Hey everyone, Tim DeStasio here, Psychrometric Saturday once again, and we've been talking about enthalpy and total heat and how total heat is broken up into two parts, sensible heat and latent heat. Here's how manufacturers rate their HVAC equipment. They use a sensible heat factor, and that's when we take our sensible and we divide it by our total. Out of our load calculation, we've got 32.5 MBH. Well, what is that? Well, a lot of manufacturers, instead of using 32,500 BTUs, they call it 32.5 MBTUs per hour, 32.5 thousand BTUs per hour. When we divide 27.4 divided by 32.5, we come up with a sensible heat ratio of 0.84. That means that the remaining 16% must be latent load, and that works out to 5.1. Trying to match a unit that will perform very similar to those numbers right there. We're looking for a total heat number that is as close as possible to our total heat load. So we're trying to match our total capacity to our total load. Are we quoting a 2.5 ton unit or a 3 ton unit? We've got to do a little bit more math. We have got to break this down and to make sure that the system that we select can handle not only the sensible, but especially the latent, because the last thing we want to do is install a system and it cannot maintain the moisture, and we have all kinds of health issues that go with that. So we've got to start doing some math. Let's say we take our 2.5 ton unit at 1100 CFM. Out of our total 31.9 MBH of capacity, 87% of that is sensible. So we got to break that down into sensible and latent numbers and compare that to our load. So in order to figure out what our sensible capacity is, we take 31.9 and we times it by 0.87, and that gives us 27.7 sensible, which means that the remaining is latent. Well, what is that? Well, we simply just have to do a little bit of math. It's 4.1 latent. And so let's compare that to our load. 27.7 sensible. Well, we are barely above that. It's okay to be a little bit above your sensible heat load, but not a whole lot. But we definitely need to meet our latent load. 4.1 compared to 5.1 of load, we're not even close. We will never be able to control the humidity in this building. So we rule the 2.5 ton unit out. That just leaves a 3 ton unit. But at what fan speed are we going to set this system up when we commission it? Well, again, we've got to do the math. We've got to take 32.9 times 0.77 sensible heat ratio. That gives us 25.3 MBH is sensible. The rest is latent. So that gives us 7.5 MBH of latent. So again, let's compare this to our load. We got 25.3 MBH of sensible. That is less than our sensible heat load. So at this fan speed, we are not able to maintain the temperature in the building. What about our latent load? Well, it looks like our latent capacity is way over our latent load. 7.5 is way higher than 5.1. So we're able to meet the latent load of the buildings. So while the system on paper may not look like it can keep up with the sensible load, which means our thermostat may not reach set point on a hot day, it definitely can maintain the latent load. Just for kicks and giggles, let's go ahead and step that airflow up to 1200 and see if those numbers get us where we need to be on both sensible and latent. So again, our total heat is 34.2. That's our total capacity. Out of that, 0.83 is sensible. That gives us 28.3 sensible, and then the rest is latent. And that gives us 5.8 latent capacity. Again, let's compare that to our load. 28.3 sensible is slightly higher than our load, so we're covered there, but we're not too oversized. And 5.8 latent also is slightly higher than our load, so this covers us very well. So it looks like our 1200 CFM 3 ton unit is where we need to go. That's going to get us really, really close. Here's one more thing to confuse the matter. According to Manual S, we can take half of the extra latent capacity and we can apply it towards sensible. So you remember here at 25.3, we didn't quite meet the sensible load, but we had a lot more than our latent load. Well, we can take half of that excess right there of latent and we can apply it towards sensible, and all of a sudden our sensible capacity becomes very close to our sensible load. load, and we are aggressively sizing this air conditioning unit. So as a contractor, what I would do is I would go ahead and sell the 3-ton unit, and I would initially actually set it up for 1050 because I want to size my systems as aggressively as possible to dehumidify as good as possible. And if for some reason that unit had trouble keeping up, I would come back and just bump up the airflow just to make a little in the field adjustment. But I would definitely not go with a 2.5-ton unit because the numbers simply don't make it work. I know I threw a lot of numbers at you. We'll be working on this some more throughout the series, but for this time, thanks for joining us on Psychrometric Saturday.